I'm so excited to be back on the air. Welcome to the Keys to AWS Optimization, and welcome, Rick. How are you doing today?
I'm doing great. It's a little early. You got me up a little early for this one, but I'm really happy to be here.
Me too. And it's late where I'm coming from the UK. And I'm just excited to be back on the airways to bring you guys all of the cost optimization, news, features, stories, everything you could do to do with your FinOps journeys. So if it is your first time with us, welcome. And if you are one of our returning fans, welcome back. We've got some exciting content for you today. But before we get into any of that, we're starting off a new little starter feature with our show, which is have you had a frugal week or a splurgy week? Rick, tell us, have you had a frugal or a splurgy week this week?
Oh, good question. So this week has been frugal. I took my family for a couple of days last week up to Whistler and we did some skiing, which was awesome. First time for my children to go skiing at Whistler. So we splurged last week. So this week is definitely frugal week. Plus, it's been snowing just off and on all week long here in Seattle. So the roads are icy. A lot of people have been just staying off the roads. And so it's been a little bit more low key, which is kind of nice.
Yeah, the fact that you said snow, I'm just like, no, 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 no. That is not my area. I do not like snow. But welcome some chat in the chat. Great to have Keys back. Yes, it is. Hello, loving that. Hi, Rick. Hi, Steph. Hello. Welcome back and welcome. Excited to see new features. Yes. So today's episode. So I'll
Oh,
do our
hold on.
film intro.
Steph,
Oh,
Lenyan just commented who built some of these features. That's funny. Hi, Lenyan.
Carinian. We'll be showing off some of the amazing products that you have. But let's do the formal intro. So, welcome everyone to the Keys to AWS Optimization, the show we share stories, concepts, and solutions to help you unlock your spend at AWS. My name is Steph Gooch. I'm a senior optimization architect advocate, bringing you all your FinOps information. And with me is Rick, who has been on the show a number of times, but we are now streaming across a bunch of different locations. So, not just Twitch, but LinkedIn, YouTube, Facebook. Pop it in the chat, guys. Where are you streaming from? Where are you watching from? YouTube, Twitch, LinkedIn, Facebook. There's too many. Pop it in, and we'd love to see where everyone is streaming from. But as always, when we have guests on, we love them to do our 1 minute origin story. So, Rick, would you just introduce yourself and tell the folks what you do and where you come from?
Absolutely. So, my name is Rick Oakes. I'm a senior manager here at AWS. I lead the product management team for all of our optimization tooling. So that's things like Compute Optimizer, Cost Optimization Hub, savings plans, reservation recommendations, those sorts of tools that help you save money. And how I got started in FinOps, that story goes back 10, 11 years. I did data center migrations. And part of that project was okay, no more funding for data centers. We're going to move to cloud. So I got my start migrating a bunch of resources to cloud. And as part of that migration journey, realizing, oh my gosh, I'm moving so many resources that nobody's using. And they are 5, 10 years old. They have low utilization or no utilization. This lift and shift approach is very costly. And so I got executive buy in to build a dashboard to show costs associated with idle and incorrectly sized resources. So I went around to different business units when I was at a different company and took this dashboard. This is 2014, and showed them the utilization rate mapped to cost and what
Mhm.
you could do to change your resource sizing and instance selection to save money. And that project was wildly successful. It was over like $100 million of savings in a 12-month span. It was an incredible project, and it sort of launched me on this career of efficiency, right sizing, being accountable for the spend
Yeah.
far before it was ever called FinOps. So ever since then, it's just been a continuation of trying to get people to right size. It's like the same conversations, but shoot, we've come so far. It's awesome.
Oh, in comparison, and I feel like you deserve a little, like, cha-ching, noise for all the savings that you made on that, which is great. And welcome, we've got people from all over, from Chicago, from New York, from Brazil, loving this. Thank you, everybody. This is awesome chatter, and we'll be relying on you to tell us more, about your feelings towards the awesome tools that we're gonna be talking in. But for those, maybe who haven't been to these before, what we wanna do is, especially if you are on, Twitch, oh my god, drop it in the chat. is this your first time watching an AWS live stream? So 1 for yes, 2 for no, and 3 for basically I live here. So you can drop some of those numbers in the chat. But we are excited to get into this episode and chat throughout. We are here to answer your questions. So if you have any questions, comments about cost optimization in general, then please drop them in and we'll make sure to bring that up and have a discussion about it. So a lot of people, is this your first live stream? No, good. We've got lots of returning people. I love it. So, Rick, why don't you give us a quick overview of what we want to be talking about today, which is the new cost optimization features in Compute Optimizer?
Absolutely. The last 3 months have been pretty exciting for us. We've had several new features launch. Stay tuned later today. You might see a little bit more. So the team is working tirelessly behind the scenes. We have an incredible engineering team that thinks about and develops optimization capabilities year round. Compute Optimizer has just an incredible engineering leadership team and set of development teams. We call them two pizza teams. Small development teams that own individual components of Compute Optimizer. And some of these launches we've done in the last 2 to 3 months are auto scaling groups where Compute Optimizer will now give you fairly advanced recommendations for auto scaling groups, where in the past it would only give you a recommendation if your auto scaling group had a fixed size of instances, fixed number. And now we've made a very powerful advancement in auto scaling groups where even if you have different types of instances and families of instances and it's scaling in and out, we've built an ML model that will detect all of these configurations, normalize all the usage data, and give you recommendations to save money and detect idle auto scaling groups. We also launched at reInvent idle recommendations, and this is one of my personal favorites because if you look at the 2024 State of the FinOps report that the FinOps Foundation puts out, the number one activity practitioners focus on is idle waste cleanup. And so we saw that and we talked to a lot of customers and we hear this and we're like, wow, there's a whole fleet of recommendation types we could go after that are easier to validate, easier to trust, easier to execute that we would love to go for. So we worked on all of that pretty much all of last year and launched 6 new idle recommendations, all in a single launch, 6 new recommendations. So that's exciting to be able to do that number of new recommendations in a single effort. And so we'll talk about that in more depth. What are those idle recommendations? What do they mean? What's the definition of them? And then another one we launched is Aurora optimization recommendations. And this is a bit of a follow-on because we launched RDS right-sizing kind of middle of last year. We actually launched it at FinOps X in San Diego.
Our little foxes in the background that we love.
So, I mean, it's really fun launching things at FinOps X, hint, hint. So, make sure to get your tickets. But what I would say is the FinOps group of people, the practitioner body, these are our customers that are deeply focused on costs and optimization and really maximizing cloud ROI. And so what we heard when we launched RDS right-sizing at FinOps X is a lot of customers came up to us and they said, thank you so much. We really wanted help optimizing our RDS spend, but we also have a lot of Aurora. When are you going to launch Aurora optimization? So we said, okay, let's do it. And the things I'm most proud of how our team handled this, because we were able to pull this into our backlog and launch it at reInvent last year in a very short time frame and deliver a lot of optimization and savings for Aurora resources in Compute Optimizer. So those are 3 really big launches that we've had in the last couple of months that we'll talk about today. We'll do a little demoing and answer some questions. And and I already see a question in the chat. What's the difference between Compute Optimizer and Trust Advisor? I love this question. This is a great question. So, as we launched the new idle recommendations, right, we did a deep dive with a lot of customers and a lot of service teams to figure out how to build a new idle recommendation that's trustworthy and accurate and something that is so safe that you can go execute against that recommendation without too much concern or worry.
Yeah.
So we did a lot of that research and had a lot of customer conversations to define a new set of criteria for what makes something idle. The Trusted Advisor checks are a little older and they're based on thresholds. So a trusted advisor check will say, is CPU below 5%? Yes or no. And so they're great leading indicators on if you have something that you need to go take a look at to see if it's not used or oversized or something like that.
Yeah.
Compute Optimizer is designed to give you a recommendation and tell you what to do to solve that recommendation, and then to show you the cost impact after all of your discounts, like savings plans and RIs and all of that sort of stuff. So they're kind of operating from a different premise that Compute Optimizer recommendations are designed for you to have a list, have the savings number related to your own individual costs in your account, and then a recommended action to take to solve that. Whereas Trusted Advisor is a check, it's saying, hey, you have low utilization, you should take a look at that. And so the actionability is a little bit different. Uh,
Yeah.
yeah,
Okay. Awesome. And chat, let us know. Is there maybe we could have some guesses before we actually bring up the share screen. Chat, what do you think if you haven't seen, what do you think is in the idle resources count? What types of resources that might be in there? Just to see if people are thinking about the FinOps mindset. But just as a quick recap, while everyone's letting us know that, could you just in like a couple of sentences explain what Compute Optimizer is for the folks who haven't seen it before?
absolutely. So Compute Optimizer is a completely free tool and product that AWS provides in the console and via APIs that looks at all of your resource utilization and configuration data. So it looks at EC2 instances, auto scaling groups, EBS volumes, databases, and it takes a look at what instances you're using today. What's the cost of those instances? What's the utilization? So CPU, memory, disk, network, IO, throughput, all of these utilization metrics. And then it takes a look at all of the available instance types you can choose from to size to. And then it does a performance analysis and says, of all of these instance types and sizes, which is the most cost efficient that has the highest performance that you need to meet the performance requirements of this workload? And so it does this analysis and gives you a resulting recommendation that says, this instance size is best. The M7i is the best instance type for your workload, or M8G, or right. And with over like 700 instance types available, it's really hard to pick the right one. And we didn't want people to have to do that one by one for every resource. So we built Compute Optimizer.
Amazing. Okay, so let's start going into the demo. So I'm going to bring up your screen. So this is like the homepage for Compute Optimizer, what people see at the start. And I already see, Rick, you've not done well. You've got some savings you could make. We could optimize this account way more.
We sure could. And I choose not to because I have to keep demoing. Yeah, we have our demo account. We leave it maybe not in the best state sometimes.
Yeah.
So we have a lot of stuff here. If you look at all of the places on the screen where it says new, you'll see on the left nav, auto scaling groups new, RDS databases new, idle resources new. These are all the places where we've added new capability.
So yeah, we're going to kick off with those idle resources so we can start seeing things that are generally costing money that you're probably not engaging with and not utilizing that you could kind of stop or delete. I hopefully delete, but the idea being that you want to flag this because not everyone notices how inefficient some of the things are.
Yeah. So the first thing we did with the idle launch is we redid the homepage of Compute Optimizer. And so you'll see savings on the left and performance improvements on the right.
Yeah.
And these are recommendations where, hey, we're noticing utilization is very high and you're having resource constraints. CPU is hitting 100% over time, or you're having IOPS or throughput pain. And so we categorize those because one of the best ways to build trust with your engineering teams is to show that Compute Optimizer is actually designed first to manage the performance of your workloads and then second, save cost. Everybody likes to look
Mm.
at the number, but we think of optimization really as the balance between performance and cost together. So these two graphs are right next to each other to show the delta, where the yin and yang between cost versus performance. So if you scroll down, you'll also see a table. This table is new, and you'll see that we look at all of the recommendation types by resource types. You have EC2 auto-scaling groups, DBs, uh, EC2 instances, EBS volumes, so on and so forth. So we're going to go ahead. So we have some idle resources. You can either click on them here in this table, or you can go to the left nav and click on the idle resource view. So we're going to do that. We're going to take a look at all of my idle. I have a lot of idle resources.
Wow.
I have idle database, RDS databases. I have an ECS on Fargate idle resource. I have some idle EBS volumes. And then you can also see how many days of data was used to make the idle determination right here. And then you'll also see a little details button if you want more information on what's the utilization of these resource types. And so you can quickly see max CPU for this database is 11%. Max IOPS is 2.4. So definitely something that is idle. But let's dive into one of these. I'm gonna grab
Yeah.
this.
Let's go for the EBS. Yeah.
Yeah, let's do this EBS volume.
So it's marked as idle, but what does that actually mean?
Yeah. So we talked to a lot of customers that wanted to understand when you see an idle recommendation, how do I know that it's idle or what your definition of idle is? So we added this button. Every time you look at an idle recommendation, you'll see this criteria button and you can click on it and it'll tell you the exact definition of what criteria was met in order for this thing to be flagged as idle. Now, in this case, the volume isn't attached to any EC2 instance over 32 days. So that definition is idle for this volume.
Right.
So
And that's why there's no recommendations, because there's nothing to do with it apart from get rid of it, right?
absolutely. And what's really interesting is there's no data because there's no attachment. This volume is sitting there unattached. And if I scroll down to all of the utilization data, there's not attached to anything. So this is really a cost. So in this case, the recommendation is that you snapshot the volume and consider deleting it. And this would give you, this volume is $8 a month. So individually, they're not incredibly expensive or anything, but collectively, you'll get in a situation where you might have hundreds or thousands of unattached volumes. And there's like some scripts that exist out there for people to do this scan themselves, but we really wanted to provide this in a user experience in the console where you can take a look at all of your idle resources across all of your accounts, right? And so we really wanted to help customers do this idle cleanup without having to do scripting or custom work or anything like that.
Yeah, there's no additional place. And hopefully people are already looking in Compute Optimizer for recommendations for optimizing whether things are too big, too small, or just right. So it's a place where they're already navigating to and can take advantage. So Cloud Without Strife says, how much does Compute Optimizer? Free, right? Free.
There's one paid feature in Compute
Right.
Optimizer. If you change Compute Optimizer's settings to use 93 days of history, that is a feature called Enhanced Infrastructure Metrics, and that's about 25 cents a month for roughly right around there.
Good to know. Awesome. Okay. And then the next one is this is just a point. Rick and his team are always putting on the best tooling. Ah, thanks, Connor. Love that. This one is, which AWS service is currently your biggest cost driver? Now, I'll jump in with this first. It depends on what you're using, because if you have all of your infrastructure in serverless, then like Lambda might be your biggest cost versus maybe a more traditional style is often EC2 is a big driver of cost, but I've had customers that spend mostly their money on S3. So it does depend on what you are actually utilizing in the cloud. And my tip for that is definitely go and check out Cost Explorer as a starting point, filter by those services, and you'll be able to see which is the biggest thing that you're spending your money on.
Yeah, actually, Steph, it's kind of interesting because we ask that question a lot of our customers and take a look at data. And that's part of how we decide what are the next features we build optimization for is we're constantly looking for what's the highest ROI of a feature we can build, help customers manage their cost drivers, right? That's why you see things like EC2, RDS, ECS tasks, EBS. These are the resources that like we talk to a lot of customers and are like, hey, help us manage the efficiency of these resources.
Brilliant. So, chat, I want to know from you, have you used the new idle feature? Let us know. One for yes, two, but you will, and three for no. We want to make sure that we check in and see what people are doing. But love, I'm excited. I'm glad to see this is like moving towards that area of bringing more people in to use this kind of stuff. Um, I've answered that, and let's see what else. Okay, so no, but I will. Great, we love that. People are going to start bringing that in. Awesome. So hopefully, you've got some new users now, right? That's exciting.
I'm worried that the one yes vote is Wenyan, who's on the team. Ask him after the stream if he was the yes.
Just double check who it was. That's brilliant. Awesome, guys. Keep coming your chat. There's some more questions in the chat. Is there any automation functionality to manage these idle resources at the moment, Rick?
There are some scripts out there, and this is one of the things that I think would make sense, Steph, maybe for you and I. Let's go write a blog post about some of the execution models companies take some of these things. That would be really cool. Um, yeah, I'm constantly meeting with customers that take the Compute Optimizer recommendations, a lot of times via export or sometimes via API, pull them into their own dashboard, so they can join it with their org structure, like business unit or org mappings, and trying to get your organizational hierarchy, your company reporting structure into a dashboard, and then joined up with the recommendations is something a lot of our biggest customers do pretty exhaustively. And then uh, they can implement execution, whether that's like a integration with CI/CD pipelines or push button or sometimes Jira tickets. Uh, some of the biggest companies are doing some pretty advanced ways to execute against these things, and it's
Yeah. And Christopher adds that can you automate the use case? So just describe it and then delete it. So yeah, with you guys can take this data, it's all in the API and kind of run with it as you will. But definitely I feel like Christopher's kind of pushing the forward for the EBS volumes and stuff like that to get the automation. Agree. Awesome. All right. What I'll do is we'll pause there for questions. Anything else, Rick, you wanted to show on the idle part?
that's it for now. But I mean, idle. One of the ideas, so we built a new API for just the idle recommendations. It needed a lot less resource utilization information than our right sizing recommendation types. So we built an entire new API just for that to make it easy for us to extend and expand in the future. And so we're excited about the future of idle recommendations. So keep your eye on that space. We're going to keep plugging away, looking at ways to help people detect unused resources and go clean them up.
And I feel like we can answer this very quickly then. Will these new insight feed into Cost Optimization Hub?
Absolutely. And so Cost Optimization Hub is also owned by my team. And we, at a high level, we look to launch everything we launch in Compute Optimizer into the hub. So you can see the total of idle savings across all resource types in a single pane of glass, a single view. And then you can like report on it, slice it, dice it by org, account name, service type, resource type, all that sort of stuff. So we're excited to continue building both the Cost Optimization Hub product and the Compute Optimizer product. We kind of think of them as two different products, but the same workflow. Like
Yeah.
Cost Optimization Hub, maybe for the FinOps persona, Compute Optimizer, maybe for the engineer.
Mm, it's an interesting point. Yeah, but I hadn't thought about that with the two different markets, which is great. Okay, and there's one more question. I don't know the answer to this, so I just wanted to ask you, Rick. The look back period ranges from 14 days to 39 oh god, I'm so dyslexic. 14 days to 93 days. Is there any specific reason for this range?
Yeah, there really is. And that's a great, this is one of the things that we debate internally exhaustively. And we don't get a chance to talk about it too often, but we're super conscious of how we pick these date ranges. So 14 days was the default when Compute Optimizer first launched, and in parts of the product, it still remains the default today. But you really want, there's some seasonality associated with usage patterns that we detect.
Yeah.
The first is a weekly utilization pattern. And you have weekend dips and weekday gains and a lot of resources, or vice versa, if you have a product that has a lot of weekend usage.
Mhm.
Uh, so 14 days gets you a higher level of confidence that you're caching those weekly patterns. And then we introduced 32 days last year. Actually, this is actually 2 years ago now. We released 32-day look back period. 32-day look back period captures a monthly pattern, and that's important. And 32 days is a completely free feature, by the way. A lot of companies just go in and set everything to 32 days, and you just all the recommendations have more than twice the number of utilization data points in the recommendations. So generally, the recommendations are a little more stable. They don't change quite as much. So 32 days will capture your monthly. And we picked 32 days because there's some months of the year that are 31, some are 28. So we picked 32, so you will always guaranteed get a full month of utilization patterns in case you do things like monthly patching or updates or launches and builds. So the 32-day feature was launched a couple years ago now. We see customers use that a lot. And then 93 days, that gets you a quarter. So if you have a quarterly workload, say you have a project that does quarter close processing or quarterly tax and earnings or something like that, and you really want to capture a full 3+ months of utilization data because you don't want to necessarily size your resources down 2.5 months and then maybe have a performance constraint for a couple of weeks at the end of a quarter, you can take a look at a full 3-month quarterly view and then Compute Optimizer. It's a very safe set of algorithms and ML models that it will look at the high usage marks and size you based on almost the peak. It's not quite peak. It uses percentile, which is a different webinar we can get into, I'm sure, Steph. But uh, it looks at high utilization marks and gives you right size recommendations that is very aware of the high usage patterns in that period of time.
Okay. All right. Thank you. That is AJ. Great question. Keep those questions coming, chat. I'm very enjoying kind of going off script with Rick, but I do want to get on to auto scaling groups, the second feature we wanted to highlight today. So chat, keep those questions coming. There's a couple more that I will pop back to. But Rick, auto scaling groups. Now this already existed, but there's been some new upgrades to it. And tell us a bit about that, and then we'll go into the demo.
Absolutely. So autoscaling groups is something Compute Optimizer has supported. Um, the way we supported it in the past was we treated it a little bit more like standalone EC2 instances, where we look at the instance size you're on, we look at all of the other instance sizes, we look at the difference in performance from different CPU models and manufacturers, Graviton, all these other options, and they give you a recommendation. But we could only do that if the number of instances in the autoscaling group didn't change. So our ML models could detect and have high confidence in the recommendation it's getting. So we spent a lot of time in 2024 working on a much more advanced version of our ML model and our logic and our approach that takes into account how an auto-scaling group is flexing up and down and in and out to add additional instances, remove instances over time, how you may have multiple instance types. Maybe you have some M5s and M6s all together. And so our model now will break down the usage and utilization of all of those different instances in your auto-scaling group. It'll normalize that utilization data, and then it'll say, okay, well, there are opportunities to move to newer families, get faster CPUs, and then what would happen is your auto-scaling group will then scale down itself more often because it has faster CPUs, so you need less of them. And it's an interesting concept because if say you're running a bunch of M5s, you haven't looked at an auto scaling group in a really long time, our recommendation may be to go to an M7i, for example.
Right.
The M7i is a lot faster. It's a lot newer. It's like 7-8 years newer. And going to such a much faster piece of hardware means that you're getting better performance on your application. Response times are better, latency is lower, so on and so forth. And you reduce the port counts. So your auto scaling group will scale down by itself if you have a min and max and your auto scaling settings configured. So this is a great way to save money and make sure you're getting that elasticity benefit of an auto scaling group. Because we noticed that a lot of people still are using M5s and older generation hardware here, and they're missing the benefit of newer generation hardware, which then has a performance and cost benefit.
Interesting. Wow. And Pravis has just put auto scaling groups are awesome. They are. And I don't think people I remember when I was engineering and I always say there was a caveat. Have been engineer for quite a while now. But when we were doing it, like we would set things up in auto scaling groups, but I didn't think we were as critical of what we were setting up in terms of, is it the right size? Like, just because it's in an auto scaling group, how do we enable the right type of scaling? And so I'll just do also a quick plug that in a few weeks' time, we are doing an episode dedicated to auto scaling groups and some amazing features that you can take advantage of when it comes to optimization. So make sure you subscribe to the channel to stay up to date with this kind of information, and you'll be able to catch us here every Thursday with that kind of stuff. But Rick, should we go into the demo to see what this data actually look like?
Yeah, let's do it. All right, so we're back here on the homepage. On the left nav, you'll see EC2 auto scaling groups, again with the new icon. So this just kind of gives you a bit of a description on what it is that changed here. The support now for mixed instance types. When an auto scaling group has a scaling policy, it's now supported with our recommendations. We're gonna go in here. I had a lot of savings. This is just demo environment, so I don't actually run an environment quite like this, but so you can see this estimated savings column. These are essentially all of these different auto scaling groups that we built out for demo purposes. But what's interesting here is in EC2 right size recommendations, you might see a recommendation save $100 or $200 a month. With an auto scaling group, you might have 50 instances in an auto scaling group or 10 or whatever. So the savings amount you get out of an auto scaling group recommendation can be a lot higher because you're talking about a group of EC2 instances that are all operating together as one unit. And so you're going to see a much higher savings dollar figure per scaling group in this area. So we've configured a bunch of these auto scaling groups with different settings. So for example, we have some with mixed instance types where, they'll have M5s and M6s or a bunch of different types. We have some that are the same. And so we set up a bunch of different scenarios just to give examples of what it looks like in a real world environment where you might have a lot of auto scaling groups that are doing different things. You'd have different application teams. They're running different workloads. And so if we take a look at some of these, we can go into one of them. I'm going to go into, here's a single instance. And it says, in this auto scaling group recommendation, our current configuration is a C5 for extra large. Well, it's like, yeah, highly utilized, very popular,
Yeah.
but a little older. And so we have a couple of options to change the instance type to a few different things. So we have a couple of graviton options here. You can also
What GD? What's GD? To XD.
this graviton, but we can also uncheck the graviton box in this dropdown if you're not ready to go to graviton.
Yeah. Well, your application doesn't need it. We don't need all the graviton people being like, I can't move. Okay, don't worry. We're looking at something else.
Go to this dropdown and unselect graviton. The recommendation will stay on x86 Intel-based type processors, so you don't have to really worry about any sort of architectural changes. So we can uncheck graviton, and now we're seeing a recommendation to go from C5 to either R6i, R5, or R7. And we changed how this works a little bit to say priority because you can add all three. The way an auto scaling group works is you can add full instance types to your auto scaling group as options. And a lot of companies did this. And we talked to a lot of companies that like adding a bunch of instance types to their auto scaling group. Because if there's a capacity issue and say R6i is not available for a few minutes in a region, you can add the next option and then it'll pick that one. And you can set them to priority. And so there's like an allocation strategy option, which this will be recommended. We're looking at a single instance size ASG, so it says not applicable. But if you have an auto scaling group with a bunch of instance types, it will tell you to set the allocation strategy to prioritized. And then you can pick which instance types are prioritized first. And so you could put the highest efficiency ones at the top. And of course, just to repeat something we talked about earlier, Compute Optimizer is always picking instance types that will satisfy the performance requirements, right? So it's giving you these recommendations that have enough CPU memory, disk, network that your application will be performant. And then it's giving you a priority order. So it really likes the R6i and the R5 extra larges, and it looks like they're the same price here. And then the third option is R7i extra large, which is just a tiny bit more expensive, but also a little faster on CPU. So you can just add all three of these instance types to your autoscaling group configuration, and it'll just pick up the highest priority one. And if that's not available, it'll go down the list to the next one.
Yeah, and then this leads into, like, this question that I was bring up now, which is when would you use different when you use autoscaling groups with different instance types? And that's what you just explained, like, if you have capacity limitations and you wanna kinda mix it up so that you can make sure you get access to
And
right?
grab one with a bunch of different stuff in it. Oh, this is single type as well. So let me find one with a bunch of different stuff.
All the different things. But yeah.
This is the same one. Hold on. I'm gonna grab. So if you have a minimum and a maximum set, and you say, okay, if CPU is above 50%, scale up, or if it's below 10%, scale down. Right? You can set these thresholds.
Yeah.
Uh, our engine will now simulate what that auto scaling group would do if you did change to a faster, newer instance,
Oh.
and it'll show you the percentage reduction in the number of hours running, instance hours. That's essentially take the number of instances and multiply by the number of hours they would run. So here's an example where we're on a C5 4 extra large. We recommend a C8G. Actually, you know what? Let me turn off Graviton again to keep that consistent. So it's saying go to a C7i Flex 4 extra large. And we're saying here, the simulation says it will reduce the CPU number of hours by 339%. So that's interesting. The instance is it's a flex, so those are burstable, and algorithm will detect that your workload is a good fit for burstable. If utilization is generally low but bursts once in a while, it's a great
Mhm.
fit for the flex instance types. And then it shows you the overall amount of savings by percentage that you're gonna get. Um,
Mhm.
I don't have price after discounts. You will in my environment. Like when you have a lot of savings plans or RIs, this after discounts column will represent. Yeah, it will your RIs and savings plans. Compute Optimizer, by the way, there's a feature if you turn on Cost Optimization Hub, or if you go into preferences, you can turn this on. And this will detect all of your savings plans and RIs and not recommend any changes that will increase cost. Because, say, if you have an RI for, I don't know, a
Yes.
C5 or an M5, it won't recommend moving away from that if that will increase your total cost, unless there's a big performance issue that you need to solve. So, the after discounts column is all about discount awareness. It's pretty cool.
Amazing. Okay, cool. That is bringing some questions from people. Does this work with ECS clusters, or are we working on this?
We're working on this. This is a great question.
There you go. Yeah, good. Christopher, I'll tell you what you can do is if you want to provide your feedback on that, drop us an email. And anybody, if you have any questions that we haven't answered today, please email us at costoptimization@amazon.com. That is where we can advocate for you, and we can make sure that we provide all that feedback that you'd like about these amazing products anytime you need them. Here we go. Let's do this one. So from Cloud Asher, is there any rule of thumb with CPU thresholds for idle and right sizing as a first round check if we don't have any memory metrics ingested?
Yeah, that's a great question. We also spend a lot of time on this question. So in the idle recommendations, we have that idle definition button you can press to see what's that threshold we are using to call something idle. Um, and you know what? I can just pull it up and take a look at it. Actually, I don't know if I have an idle EC2, but you can always just go in here and click on something like ECS service on Fargate, and then you can click this idle criteria. Now, ECS on Fargate, the criteria is below peak CPU and memory, which we always have memory for ECS Fargate, below 1% over 14 days straight. Right. And so you can go into those idle recommendations and see what that threshold is. But I want to talk about memory for just a second because it's part of your question, Cloud Asher. And what I would say there is if you don't have memory enabled, the criteria changes because you may be in a situation where you're at the smallest instance size you can go to. without downsizing memory. And this is a big part of Compute Optimizer. Uh, you enable memory, the amount of savings that the recommendations show you and provide is sometimes up to 400% higher. And that's because, say you're on a 4-core instance. If
Yeah.
if we don't have memory data, we're not going to tell you to go to a instance with less memory. Say you have 16 gigs of memory. It won't recommend 8 gigs or 4 gigs or whatever because it doesn't know if that's a safe decision to make. And when we're building Compute Optimizer and designing these features, our cardinal rule is do no harm. Always provide a safe and that will not hurt an application. We have to build trust with our engineering counterpart. We must provide recommendations that are very safe and very conservative. And you can still save a significant amount of money, your resources, just by not 10x oversizing and things like that. So if you are on an instance where you have the cheapest instance for that amount of memory, the threshold kind of doesn't matter as much. You probably shouldn't go down memory size unless you really know for sure that that's a safe thing to do. Because you might have a resource that you're running and it's heavily memory intensive and your CPU is really low. And so unless you can detect that, I wouldn't necessarily go delete things.
Yeah. And there's a I feel like AJ is part of the crew. Like, does he know what we're going to talk about? Because he said CloudWatch is the only way we can get memory stats. Is there any other way? Yes, there is. You can ingest data from data sources that you already have probably set up on your compute, such as, okay, let me see if I can remember. There's Dynatrace.
I just clicked on it. Like I can just, because I have it open on my screen. Okay, you go down here to preferences, you click on general, and then there's just this button called external metrics ingestion, which is something we launched. Actually, it was one of my first launches when I joined the company.
Was it? I didn't realize that. That's pretty
Yeah,
cool.
and you can pick where you want to get memory data from. And the engineering team that built this is brilliant. They figured out and designed this so it's like literally a single click. You click what one of these APM products you have. So you
Yeah.
have Instana, and then you just click enable, and it turns on a data pipeline from Instana, a protected, completely secure, and totally free data pipeline from this company and your environment into Compute Optimizer. And then it has a link to that provider's website with the instructions on how to enable it on their side as well. So again, completely free way to adjust memory metrics, which we were so excited about this launch because getting that memory data increases the value of Compute Optimizer recommendations so much. 400% is not uncommon.
Yeah. The savings are crazy. It just enable it. And but I think we used to have early days, obviously before this release, customer be like, but we're paying for this other service. You don't want to do CloudWatch. And now you don't have to. There's kind of couple of different posts on this, but I'll just summarize with auto scaling groups with Spot. So how does Compute Optimizer deal with those kind of recommendations?
So right now it doesn't support spot because spot pricing is so dynamic. Um,
Right.
and that makes it an interesting opportunity because you can use spot with auto scaling groups and go for a fairly efficient approach if your application is highly stateless and designed to be able to add and remove instances very gracefully. And so I'd say that like when we talk to a lot of customers, there's a certain percentage of their applications that can do this, and there's a certain percent that can't. And there's even some pretty good third-party products out there too that will do a lot of the spot work for you to help get these applications to be super compatible with Spot. Because the whole thing with Spot is that those instances might drop and go away at any time if they need to be reclaimed, which is why you get such a large discount. Um, so that's definitely an option to run very efficient auto scaling groups. And this is something that we're thinking about in the Compute Optimizer space. Hey, how do we ingest the spot pricing? And so we're going to keep working on that as well.
Perfect. Okay, on to our last bit, and this is talking about our Aurora recommendations. So this, as you said, was a new feature we released RDS middle of last year, and the Aurora recommendations are a part of that. Should we just go straight into the demo for this bit?
Absolutely. So I clicked on the RDS databases nav on the left side. Again, you'll see the new button. We now support Aurora MySQL and Aurora PostgreSQL database engines. So you'll see these in this DB cluster identifier. You'll be able to see what engine is running. And so you see Aurora MySQL. This will now show up. So if you're running any Aurora MySQL or PostgreSQL, you'll see that in here. You'll see a column for idle. So we have, as part of this feature, launched idle detection for all of your RDS and Aurora instances. And the idle definition for this one is a little more complicated because we get so much more data for an Aurora instance. So I can take a look at an idle equals true and show you what that looks like because it's interesting. So here's the explanation, and you can feel free to dive into this. There's a learn more button as well. The complexity here is a little higher because we're looking at a lot more information to detect if something is idle. And you'll see that performance status is optimized and idle is a yes, because again, we don't downsize or provide recommendations to downsize memory capacity. And that's even more critical with databases because memory is very precious to databases. And so we're very sensitive here. And so if you have a certain amount of memory capacity, we will keep that the same. So you'll see different recommendations and options. In this case, it's telling you to do a generational upgrade from an R5 to an R7i. And then again, if you have any commitments or discounts, those will be factored in here. And in this case, it's the same price. So this is one of those things where we're saying, hey, you can get on faster hardware here for no additional cost increase. And then we're doing things like looking at DB load, memory utilization, database connections count, which is one of the criterias for idle. So we're doing a lot more than just looking at CPU when we're making these decisions in the Aurora space. Database connections count is one of those pieces of data that's really insightful to understand, is this thing idle? Is anybody connecting to it? Is anybody using it? As well as DB load. These are some of the metrics we're using to define idle.
Right.
What we noticed is, like, depending on the different CPU count and capacity, the idle CPU utilization will be different because there's a certain amount of overhead that Aurora is using to manage and maintain itself and run. And so the idle criteria is a little bit different for each size. And so that's why we're using sort of a combination and a complex definition of idle that's CPU, DB load, DB connections, network, all of these things are factored in.
Just not one thing. Amazing.
It's a very complex, multi-dimensional definition of idle.
Yeah.
You can see, like, all of the data that's pulled into Compute Optimizer to make this decision. This
I loved it. It's that. It's so helpful to make the decision because it's not just being like, oh, you should right size. There's actual reasons behind it.
Yeah, gone are the days of right sizing on CPU average. We have to gain the trust of DBAs. One of the things that my team did when we were designing this is we talked to some of the brightest minds in the database industry to go figure out what is the safest criteria, what's the most trustworthy criteria that if a DBA, in our case, our senior principal, high level, engineers that they have spent decades working on databases, what would you call an idle database? And then taking that definition from those principal engineers and then talking to a bunch of customers to validate, would you agree if this considered idle? And then setting that definition for every instance size.
Yeah.
So the team did tremendous investigation and work.
I like this question in general. How to improve efficiency and reduce costs? I think I'll give you a high level answer for this one, which is definitely go and check out the native tools that you've got. Cost Optimization Hub that Rick mentioned at the start earlier is the stop shop of everything, so you can kind of see that information and start to explore that billing console and start to see things like Cost Explorer to learn where you're spending money. Check out the new Savings Time Analyzer that we've kind of released. It's on the Amazon YouTube channel. If you search for that, you can see a demo of how to utilize that tool that provides you with recommendations or purchase options, and then making sure that you access your optimization data. So check out the billing console. That would be my kind of top tip for this area, I think I'd say. And the last one, which is, so I don't see your show on AWS On Air. How do I know when it's next airing? Great question. We are here every Thursday. Oh, the time zones, 8 a.m. Pacific time, 11 Eastern time, and 4 for anybody in the UK. But if you want to make sure to stay up to date with all of the episodes that we have and all of the different information, you can check out community youtube.com/livestream/AWS Optimization. And on there, there'll be a list of all of our episodes. I can actually show you what that looks like. And this way you can see kind of what we have for the next couple of weeks and any links to any historical episodes and all the places that you can catch us until you check out that page. Right, we have a little bit of time left, and I know, Rick, you wanted to ask kind of a quick high-level question and discuss, like, how customers should track success over time. So they start taking on all these optimizations. How do they see if it's going well? Just maybe we might have to do a whole nother episode into diving into this, but do you want to explain a little bit about that?
I do. And let me take a look to see if this is something I can pull up on the screen. But so we have a cost optimization hub product.
Mhm.
Yeah, can you flip me back to screen share? Oh, so this is the cost optimization hub product, and again, like whenever those new recommendations, they'll they'll show up here as well. You'll see at the bottom the total savings you have. So for me in this demo environment is about 3,000 a month, split across a bunch of different recommendation types. It says here at the bottom, your estimated savings is 2,987 per month, which represents 23% of your last 30 days AWS spent.
Wait, where do you see the 23%? Over there. Okay. Look.
Kind of small and like yeah, I want to do more here. Like so we've got our brightest minds here thinking about how we what the future of measurement of optimization is. But when you're looking at all of the savings, and we have a lot of recommendations now, right? With EC2, auto scaling group, RDS, EBS, right? All of this stuff, it's difficult to know where to get started, right? And the complications of, okay, how difficult is a recommendation to execute versus how much savings there is, and you have to constantly measure, where do I get started? So one of the things that I recommend is taking the savings number and then dividing it by your total AWS spend, whether that's like monthly or daily or what have you. And you get an efficiency metric. You get a bit of a KPI here that is really valuable to track, because ideally the savings number goes down, or if it's going up, it's still going down relative to your total AWS spend, right? So it's okay if the optimization number potential goes up if your AWS spend is going up a lot and the growth of the optimization potential is going up less, right? And so it's that relative measurement of how much can I save versus how much am I spending. So let's break it down into a really, really simple sentence, right? You could say, oh, 23% of my AWS cost could be optimized. And you can trend that over time. And the cost intelligence dashboards do this, and there's some third-party products to do this, where you can do this yourself by using the hub and benchmarking that percentage. So our recommendation is to take a look at this. You can take a look at it by business and by service, or you can break it down by whatever dimensions make sense for your business to help benchmark and measure teams against each other, or provide carrots and praise for organizations that are doing very well in driving this number down, the efficiency optimization or savings number down. And so this is one of the areas where I'd love to see what we do as an industry, as an optimization industry, over the next 12 to 18 months on developing KPIs. And the KPI conversation has been going on for a while in the FinOps industry and with the foundation. And cost visibility KPIs have made a lot of maturity with cost accountability, cost tagging, unit metrics and unit economics. And I'm really excited to see more maturity in the optimization space for KPIs. And so I think we have it. I think we have it here in Cost Optimization Hub, available for everybody to use. And I'm excited to see what customers do with it.
Awesome. Yeah, and there's been some great comments. The let me pull these up. So, just some thank yous. So very helpful information. Thank you so much. That is great. And awesome information. Thank you, Rick and Steph. Love this. And there's also we'd love to see that metric and track potential savings. Yes. And as I said earlier, don't forget that you can share on the email address costoptimization@amazon.com. com, and that is where you can share any feedback or speak to your amazing account teams. At the moment, like you said, Pete here is using one of the cloud intelligence dashboards. Go and check out other episodes to learn more about all those amazing intelligence dashboards so that we can share. You can learn all about all the things that they do, all the different avenues that they share, costs. And this last one, thank you. I appreciate you guys taking time to explain new optimization strategies that AWS has introduced. These are definitely well thought out tools. Yes, they are. Isn't Rick's team amazing? I feel like whenever you come on, Rick, we would do this. We share those things. For the links, I will check out once this is published, and we'll make sure we put those in comments below. But feel free to Google those as we can. 2 minutes left, Rick. Anything else you want to add?
Yeah, I would just want to say that like that customer feedback that we received, whether you're in the FinOps Foundation as a practitioner, or you're giving feedback to your account teams, or you're directly reaching out to my team or Steph, that feedback is what's driving our roadmap. So we take feedback seriously. We love talking to customers. Do not be afraid to send emails to the cost optimization email address and give that feedback to us, because we love it. Feedback is a gift. And one of the reasons why we've been able to move very quickly and build a lot of these capabilities, and will continue to do so, is because we love listening and understanding what are the things we can do that have the biggest impact on your ability to execute an optimization program or project. So please continue that. And again, shout out to my wonderful engineering organization that works tirelessly. They worked really, oh, sorry. They worked really hard. They worked really hard last night to make sure this demo environment was good and everything. And I just really appreciate them and all the work they provide.
Awesome. Okay. All right. Thank you so much, everyone, for joining. Great questions. Feel free to connect with us on LinkedIn. You can search for us on there, and make sure you follow all the channels that you've seen these on, and check out things like the YouTube channel, and like and subscribe. Hit those buttons. But we'll be back next week talking about finance versus engineering when it comes to FinOps, and having that great debate. That is all from us. Thank you so much, and we'll see you next week. Bye, everyone.